Let's rewrite this fx as 1 plus x to the power of 2 to the power of minus 1. So f prime x is going to be equal to negative 1 plus x squared to the power of minus 2. And according to chain rule, we will differentiate this, which is 1 plus 2x. That means what I have is a negative 1 plus 2x divided by 1 plus x squared and the whole thing squared. In order for us to expand this by using the binomial expansion, we need two terms, but there are three terms here, so I'm going to regroup them into two terms, 1 and x plus x squared. This to the power of minus 1, so expanding this using binomial expansion, it is going to be 1 plus minus 1, then x plus x squared plus minus 1 minus 2 divided by 2 factorial, then x plus x squared square. And since we need to expand it up to the x to the power of 3 terms, I'm going to write down one more term. So minus 1 minus 2 minus 3 divided by 3 factorial, x plus x squared to the power of 3 and so on. So what I have here is 1 minus x plus x squared. Then this divided by this is 1. So, and expanding this, the first term, it will become x squared plus 2 times of the first term and the second term, so 2 times of x times x squared, x to the power of 3, and the other term is going to be x squared, so it is x to the power of 4, I'm going to ignore it. Then this is going to give me a minus 1, so negative of this. If I were to expand, I'm just going to keep the first term. The rest of the terms are going to be higher than x to the power of 3. So for what I have here, if I were to simplify, I'm going to get a 1 minus x plus x cubed, and so on. According to the question, we are supposed to come up with the Maclaurin series of this. And if you were to just focus on the first term here, it reminds us of what we have gotten from the first part of the question, that is f prime x. And in the second part of the question, we have another representation of fx, which is this, which means that we can also find another representation of this by differentiating this. So f prime x is going to be minus 1 plus 3x squared and so on, which means that this over here can actually be re-expressed as minus 1 plus 3x squared. As for this over here, I'm going to make use of what I have in the list of formula, which is this sine x has another representation in the Maclaurin series, and I'm going to replace all the x by 3x, which means that this is going to be re-represented as 3x, then minus 3x to the power of 3, but that will give me x to the power of 3, which is not what I want according to the question. We just need to expand it up to the term that is including x squared, which means that this is where I'm going to stop. Okay, and if I were to simplify this, my Maclaurin series for this entire expression here is just simply minus 1 plus 3x plus 3x squared. In part 2 of the question, we try to re-express fx in this binomial expanded form, which means that this form over here requires a validity. So let's try to calculate the validity of our binomial expansion. For the validity, it is going to be the modulus of the second term, x plus x squared modulus. This must be less than 1. I'm going to try to attempt to solve for the inequality here, and if I were to make use of our graphing calculator, our graphing calculator gives us a graph of y is equal to modulus of x plus x squared as something like this. And if I were to draw y is equal to 1, it is this. So if I were to take these two values here from my graphing calculator, this is minus 1.6180 and this is 0.61803. So from what I can see here, the validity is such that x is supposed to be bigger than minus 1.6180 and less than 0.61803. And if you were to look at the integral that we are supposed to evaluate, it is starting from 0 to 1. And 0 to 1 is not a subset of the validity of the binomial expansion. That is why if I were to use this to replace fx and attempt to calculate the value of this, the value that we try to approximate is not going to be valid.